to address graphing exponential functions. Okay, so this is like the general version of an exponential function. And we know each of these parts. We know specifically the two easy ones, the v and the h. V, that's pretty much our vertical shift up and down, and h is going to be our horizontal shift, horizontal left and right. Now a is a tricky one. A kind of has two things on it. So a will pretty much tell you where the graph is going to intersect on the y-axis. So you can call it y-intercept. It's at the beginning, so make sure to address whatever the a value is. Make sure to address that first, all right? So your y-intercept. It also represents the amplitude. The amplitude. What do I mean by amplitude? Amplitude is pretty much how far away is that point of intersection away from your horizontal asymptote. All right, so I'll give you examples of that in a second. Well, let's actually do that right now. So let's say that we have a function of a vets given to be 7 and then e to the x. In this case, there's only one transformation. This 7. Well, on a way, it's in the y-axis. Again, we know this is the y-intercept. So my point, it's going to be there at 7. There's my point. Now, where's my x-axis? Usually the x-axis is like 1 unit below. That's assuming that would be a 1. But because it's 7, my asymptote has to be 7 units away. So my asymptote, it's right on the x-axis. It's 7 units away from my point of intersection. So this graph would look something like this. Sorry, it's supposed to go through this point. It's going to look something like this, going through point 7. All right? Well, let's add another parameter. Let's say g of x to be equals to that same 7, and then e raised to the x power, and let's go shift everything plus 2. All right, so we have another x and y axis, and we have again our graph starts at, we know always the asymptote, it's right on top of the x axis. The 7 means that my point is going to be 7 units up. So there's my point, 7 units up. So there's my 7. There's my point. That's because of the 7. My 7 and the asymptote it's set, which is 7 units away. Okay, now because of this plus 2, this is what's going to happen. Because of that plus 2, everything is going to shift 2 units up. So the 7, it's going to go 2 units up. Let's see, up here, it'll go. So 7, 8, 9. My point has now shifted to my y to be 9. But that's not the only thing that's shifting up 2 units. My asymptote also has to shift 2 units up. So my asymptote is not at point 2. My graph would look now something like this, and going through this point. All right, so pretty much everything was shifted 2 units up. Let's add now another parameter. Let's call this now h of x to be equals to 7 times e raised to the x. Let's shift it minus to the left, to the right, 1 unit, and then plus 3. All right, so here's my graph. Again, because of this 7, again, my asymptote begins all the time, always on the x-axis. 7, that's where my point begins. It begins at 7. There's my point at 7. Now, everything has to be shifted up 3 units. So my asymptote is going to be shifting up 3 units. There's my asymptote shifted to 0.3. My asymptote is 3 units up. This 7 has to also shift 3 units up. It's not at 7 anymore. Now it's at 10. Shifted 3 units up. But that's not it. we have this -1. Everything has to shift to the right 1 unit. Well, you can shift. Do you want to shift the asymptote to the right 3 a unit? You can do that. I think it'll make no difference because it's horizontal. So it'll stay there. But this point, you can shift it up you can shift it left, right 1 unit. Boom. It'll be there now. This is my new point, and it's at 1, 10. And my graph will look like this. I'm going through this point. All right. So that's kind of an example. Now let me do 2 of the problems that are on your test. Here's the answer for one of them. So here's the first one. So there's my 3. So pretty much my graph has to be it originally started up there at 3. And my asymptote, of course, started on my x-axis. Well, notice, everything had to shift 2 units down. My asymptote, boom, shifted 2 units down. And my point, my asymptote also shifted 2 units down. Okay, so my answer, we don't need this. We don't need this. We need only the final piece of it. Okay, the end behavior. The end behavior, it's that as y keeps going, actually is that as x goes to infinity, my y value also goes to infinity. Stating the domain and the range. Well, it goes from left to negative infinity all the way to right to positive infinity. So my domain, left and right, it's negative infinity to positive infinity. My range, well, notice it doesn't go farther down than -2. -2 is the lowest it'll go, but it's not going to touch -2. That's why we're going to use parentheses -2. If we were to use a bracket -2, that means that it's touching -2, but it's not going to touch -2. Okay, and it's going to go up to infinity. So that's my domain. Now let me approach this problem. The problem 10. Actually, let me get another paper for -10 and for -10 for problem number 10. Okay, so for problem number 10, we have a few things going on. So you gotta be careful with this -5. This -5 represents decay. So in a regular graph, this represents growth. Decay, it's drawn like this. All right, so but everything is the same. The points and the asymptote, it's the same. All right, so let's see. In this occasion, we have a negative. In this case, it's -1. All right, it's -1. That means that my point of intersection, it's going to be at -1. There's my point of intersection. My asymptote, of course, it always starts on the x-axis. So that's that and that. Now everything has to shift 8 units up. So let's take my asymptote and I'm going to shift it 1, 2, 3, 4, 5, 6, 7, 8 units up. My asymptote, it's now there, which is at 0.8. My point, which is at -1, it also has to shift 8 units up. It'll shift up there at 0.7. All right, and lastly, we have this -1. Well, that -1, it'll make it go to the right, 1 unit. So there it is, and it's going to go to the right, 1 unit. My point is now there, which that is at 1,7. There's my point. All right, also remember that this is a decay problem, but it's negative. So growth would be like this. It's now decay, which has to be like this. All right. How did I know? Maybe you would be like wondering, why would I draw it like this? Well, I know this is the positive growth. This would be negative growth. This is positive decay. This would be negative decay, which in this case, it's this one, negative and 0.5 decay, negative decay. So this is how my graph is going to end up looking like. And this is it for in terms of writing these. Oh, well, part B, also really important. Make sure to state the intercepts and the asymptote. So my intercept is at 1,7. And my asymptote is at y equals 8. And that's it for this problem. Well, is the graph increasing or decreasing? Well, the graph is, of course, increasing. Over what intervals? It's increasing over all intervals. So this graph, it's increasing over it's increasing from negative infinity all the way to positive infinity. All right, so this graph increases on all intervals. And that's it for this problem.